Hello and welcome once again to this channel. Today we are going to focus on matrix multiplication, 2 by 2, order of 2 by 2 and 3 by 3. So matrix multiplication, before you do any multiplication, first you have to establish the order of a matrix. So the order of a matrix is the number of rows and the number of columns that a matrix has. So in this specific case, for instance, matrix A is of order 2 by 2. Then matrix B is of order 2 by 2. They have a similar order. So to add them, assuming we are making an addition, they have to be exactly the same order. Otherwise, you cannot add matrices that are of a different order. But for multiplication, the order can vary, but for example, now the number of columns in this matrix has to be equal to the number of rows in this matrix. So that's when we say they are conformable. So first we're going to multiply matrices in the normal way. Then we're going to use an Excel function that multiplies matrices automatically. So the normal way of multiplying matrices is you take the first row elements you multiplied by the first column elements. Then again the first row elements by the second column elements, and so forth. So the first part of multiplication is this value multiplied by this value, but I'm going to lock this cell because we are going to reference it in the next column. So it's positive 1 times 4 plus negative 8. This value we are going to lock it again with the 4. Negative 8 times negative 3. So we'll get a value of 28. Then I'm going to drag this across to get the value when you multiply this row and this column. As you can see in this formula, we have multiplied that row by that column. So we are done with the first row of the first matrix. Let's go to the second row. The second row will be 6 times 4 plus 6 times negative 3. Then the other will be 6 times 3 plus 6 times 0. So we are going to multiply this value. Again, I lock it with a 4 because we are referencing it. Times that plus that. Again, I lock it with a 4 times that. Then I drag it across. So when you multiply the matrices A and B, the value you will get will be this. It's still a 2 by 2 matrix, and you can confirm it because the number of rows that are in this matrix are 2. The number of columns in this matrix are also 2. So that's how you multiply in the normal way, the normal sense, when you're not using any Excel function. So let me highlight this matrix in blue. Now, assuming that you are using a function, so the Excel function that we are going to refer to in this case is mmult. So matrix multiplication. So you have to highlight the first array of matrices and the second array of matrices. So using an Excel function, let me get that result here. You will type equals, then let me zoom in a bit. Yes, that's good enough. So you'll type equals, then mmult. And as you can see, it says it returns the matrix products of two arrays, an array with the same number of rows as array 1 and columns as array 2. So the number of rows in array 1 should be equal to the number of columns in array 2. That's when you multiply. So highlight array 1. So array 1 is from B2 to C3. Then put a comma. Then highlight array 2. Then put an equal sign. So the matrix automatically populates itself. We have 28, 3, 6, and 18. So that's how you do multiplication using a function of Excel. So those are for 2 by 2 matrices. The same applies if it's a 3 by 3 matrix as well. So let me highlight this in bold. So this is using that function. So for 3 by 3 matrix, it's the same thing. First I'm going to multiply in the normal way. So the normal way is you take this value in this row, of course you reference it, multiplied by that, plus this other value, of course I reference it again, F4, multiplied by that value, and then again I take -8, I reference it, I log it, then I multiply with this value 3 here, then I press enter. Then when I drag across, it will auto-populate for the first row. So I do the same for the second row and the third row. So I take this value, of course, I lock it, multiplied by that, plus this other value, I lock it as well, multiplied by that, plus this other value, I lock it, multiplied by that value. Then I drag it across so that it picks the other values. Let's confirm whether it has picked. Yes, it's actually correct. Then the last row will be this value, I lock it as well, multiplied by this, plus this other value, I lock it, multiplied by this, plus the last value, this one, I lock it, then I multiply by this value. I think I've made an error, so let me start again. So we start with this value. I think I have to open a bracket. So this value, I lock it, multiplied by that, plus this value, I lock it as well, multiplied by that, plus this value, I lock it as well, and I multiply it by that. Yes, now we have a good value here. So according to the normal way of multiplying, the manual way, if I may call it that, those are the values that we are going to get. Now using mmult, if I use the mmult function, so let me multiply it here. So I'll say mmult, then I highlight array 1, which has the matrix A, a comma, then I highlight array 2, which has the matrix B. I press enter, it automatically populates the other columns of this matrix. So the actual matrix, let me highlight it in red and bold, is 2, -16, 8, -12, 4, -4, 10, -25, 21, exactly the same. So that's how you multiply matrices in Excel and the manual way. Now, what about getting the determinant? So first we start with a 2 by 2 matrix. So for a 2 by 2 matrix, the determinant, so let's have an example of a matrix. Maybe 4, 5, and 6, 7. Let's have such a matrix A. Let's have a matrix A. Let me increase the font size to around that. Yeah, that's good enough. So to get the determinant of matrix A, so before I get to the determinant, you can only get the determinant from an order of 2 by 2 or 1 by 1. From 1 by 1, 2 by 2, so it has to be a square matrix. You can only get the determinants for square matrices, if I may say so. So the determinant of A, what we normally do is we multiply these elements in the main diagonal, then we less the elements, the multiplication of the elements in the other diagonal. So in this case, determinant of A will be 4 times 7 minus 6 times 5. So the determinant is -2. However, you can also use Excel function. So we call it determinant, if I'm not wrong. Let me see how it's called. Yes, determ. So you get the determinant of an array of matrices. Determ. So that will be very simple. The determinant of A, you just type determ, so it returns the matrix determinant of an array. So this is the array that we have. Press enter, you get the same value of -2. So that's how you get a determinant for a 2 by 2 matrix. However, for a 3 by 3, the process is a bit elongated in the manual way, if I may say so. So I'm going to highlight the 3 by 3 first of all, using the manual, not the manual, the automated way, then the manual way. So let's copy this matrix and try to establish the determinant of this matrix in both ways. Actually, we can start with the manual way, then we go to the automated way, or the Excel way. So let's call this matrix B. So to get the determinant of B, first of all you have to get minor matrices after considering the first row elements. So what we'll do, you take the first element in the first row, which is 2, but it has to be a positive, so +2. Then multiply it with the minor matrix that is formed. So a minor matrix is the matrix that remains after you remove all the elements in the first row and the first column that 2 is located in. So let me highlight them in red. So when you remove these elements in forming the minor matrix, what you remain with is 5, -6, 3, and 2. So that's the first element. Yet it has to start with a positive, then you write the minor matrix that remains. So let me highlight this in a border to highlight that it's a matrix. So in the resulting sum, at the end, we have to get the determinant of this, then we multiply it by the element in the first row. So it starts with a +2. Then the next one has to be a negative, so -4. But now I have to get another minor matrix, this time while making reference to +4. So let me remove the coloring so that I can highlight the respective rows and columns. So let's go to 4. So 4 is located in row 1 and column 2. So I have to ignore row 1 and column 2 to get the minor matrix that remains. So let me highlight it in red. So what remains as our minor matrix when 4 is considered is 0, -1, -6, and 2. The same case, I have to get the determinant of this, then I multiply by this, then eventually I add up everything. So now let's go to the last one. The last one is -8. So we only calculate the determinant using the first row elements. We don't consider the other rows. We only consider the first row elements. So it goes with the signage plus, then minus, then -8 will have a plus. So it will be plus -8, which will essentially be a negative, because a positive times a negative is a negative. Then let me highlight this to have borders. So when 8 is considered, -8 is considered, -8 is in row 1, column 3. So what will remain after ignoring the elements in row 1 and column 3 will be the minor matrix. The minor matrix that remains in this case will be 0, 5, -1, 3. Yes, so that's what remains. So now we have to get the determinant, but to get the determinant first we have to get the determinants of these, the determinants of each of these 2 by 2 matrices. Yes, so determinant of B will be equal to, so first of all let me highlight, will be plus 2 multiplied by, so the determinant of this will be 5 times 2, that is 10. So let me just write it. So 10 minus 3 times negative 6, that is negative 18, minus 4, that is the second element, minus 4, then the determinant will be 0 times 2, which is 0, minus negative 1 times negative 6, that is positive 6. Then the last one will be positive times negative 8, that will be negative 8, plus negative 8 into, let me make a bracket, negative 8 multiplied by 0 times 3, that is 0, minus negative 1 times 5, that is negative 5. So the determinant will be, now I can calculate it, positive 2 times 10 minus minus 18, that is 28, minus 4 times 0 minus 6, that is negative 6, then plus negative 8 times 0 minus minus 5, that is positive 5. So the determinant is 40. Determinant of B is 40. Using mdeterm now, the matrix function, so using mdeterm, I'm going simply to highlight that array, determinant of B. So it will be mdeterm, the array that I'm considering is this array. The determinant is exactly the same at 40. So that's how you get the determinant in the manual way and the Excel way, which is pretty easy, as you can see. So thank you, and don't forget to subscribe, like, and share this video.